Welcome to part 3 of this. I might do part 2 later, but this is part 3 right here. So we have this program and we want to find the value of our 0, 1, 2, 3, and 4 in hexadecimal after executing the following program. So let's start off. This one has memory mapping involved. So that's when we have to write out all these values here. So we start off with just like all zeros and then we skip by 4. So this is gonna be 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But instead of writing like 1, 2, 3, 4, 5, 6, 7, 8, I'm just writing it quickly by counting up by 4s in hexadecimal. And then so 4, 8C, 10, 14, 18, 1C, 20, because that's like writing all that. But I'm just doing it the lazy way. And then each of these lines here, like this, and this, each of them take up 4 boxes. So like down here, 1, 2, 3, 4. So 4 boxes is 1 line. So that's, I wrote them each out on its own line because they each take up 1 line in the memory. And then, same with loopy-loop. Sorry. That goes down loopy-loop. So then when we have the DCD, that's going to start here at 1C. Or sorry, it would be technically 19. It would start here. So for DCD, how you know like what one it is you can think of big white dicks. So think of the first letters of big white dicks. So you have big white dicks. That's just the order that they go in terms of size. And then they all start with DC. DC, DC. You don't have to remember the DC part because it's always going to be there. DC, B, W, or D. And then you start out. So this one is equal to 1. And then you just keep multiplying by 2. So 2 and 4. That's why you memorize them in this order so that you know you just have to remember 1, 2, 4 in this order. And then you can just associate them. So these are all DCD. Yeah, these are all DCD. So they're all going to be 4. So just like these, how each of these took up 4 or a whole row, each of these DCDs are going to take up a whole row. And then also we have DCD, we have a value, comma. So this is the same as running DCD 0x11, DCD 0x22, DCD 0x33, and then so on and so forth. It's just quicker just to write it all on 1 line. But we know that DCD takes up 4, and then so it's going to be 4, 4, 4. So it's going to be 11, 22, 33. So let's write that out. So this is in hex, 11 is just like a bunch of zeros and 11. And the next one's 22, 33, 44, and I think it went to 55. Yeah. And then, so we have the exact same thing. These could all literally be written in 1 line. But they just have it separated into each lines, but they're all DCD and they all take up 4. So each of these different numbers is going to take up its own line. And it goes all the way up until FF. So let's go 5, 6, 7, 8, 9, A, B, C, D, E, F. Got it? Now let's go through and figure out what the values of all the registers are. So R1, I don't know why it keeps getting blurry, but R1 is equal to R0 is just equal to C, 0xC. And then we have R1 is equal to, move that over, is equal to 0x1. R2 is equal to 0x8, R3 is equal to 0x30, and then this is where we get something funny going on. So, basically this line right here could be written in 2 separate lines because it's like 2 different things that you're doing, but they read it all in 1 line. So the first part that you do is you load not the value of R3, but the value at location R3 into R4. And then you do ASR #2 on like R2, and then you add that to R3. So let's start with the first part. So LDR number 4, so it's gonna take, because it's loading. Okay, so the square brackets mean that we do this part first, because like bedmass, brackets first, we do this part first and then this part second. And then LDR, that's when you load whatever is in there. So let's start with doing this part first. So we need to find what's at location R3. So R3 is equal to 30. And if we go down in the memory mapping, 30 is equal to 66. So the value of R4 is actually equal to 66 because it's taking the value at location R3. And then the next part that we do is we have to do a arithmetic shift right by 2 onto R2. So R2 is just like a bunch of zeros and then a 1 0 0 0. So if we shift it to the right, that's when we add an arithmetic shift right. That's when we pad it with like the sign bit. The sign bit here is just 0 because these are all zeros here. So we're gonna pad it with 2 extra zeros, and we're gonna shift everything right. So we get rid of these 2, and so we end up with a bunch of zeros and then a 1 0 at the end. 1 0. So so R2, like this temporary R2, we're not changing the value of R2, we're just like manipulating R2, is now set to 10, which is just 2. And then we have to find the 2's complement of that because we want to find negative R2. So 0x2. So remember that how that was just like a 1 0 and then a bunch of zeros. So if we 2's complement that, that's going to be 0 1 and then a bunch of 1s. Now we have to add this, so I'm actually going to write this out. So that was like 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 0. And then we have to add that to R3, and R3 is 0x30. So these are 2 separate values. So let's start with the 0, so it's just 4 zeros, and then 3 in binary is just 0 0 1 1, and then the rest of these are zeros. Now we have to add those up. So 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 1 is 0 with a carry, 1 1 1 is 1 with a carry, and then that is 0 with a carry, 0 with a carry, and then it's going to go all the way over with the last one having a carry, and then these are all zeros. So the carry, we don't worry about we don't have to update any flags in this program, so we just ignore the carry for now. But now we have R3 is now equal to whatever this value is, which is, that's a 2, and then that's an E. My computer's turned off. Okay. Oh, fuck. Okay. Now, so R3, we're going to change that from 0x30 to become 0x2e, because we just convert that to hex. Okay. Now, you're done with that like 2-part line. And then this last line that we have to worry about is add. So we're basically adding these 2 values and then putting it into that. So R3, we have that. That's simple. Now let's find the value of this. So what this is doing is we're taking R2 and we're logically shifting it left by R0. And R0 is C, which is the same as 12. So you're going to shift it over 12 times to the left. So let's start by shifting it. So 1 2 3 4 5 6 7 8 9 A B C, or 12. That's the same thing. And then we take the value of R2, which is 8, which is just 1,000, and the rest are going to be zeros. So now this is that's how we got like this number here. And then we add it to R3. And R3 we said is 2E. So E is 1, 1, 1, 0, and then 2 is just 1, 0. Got it? Okay, now we're going to add them. So 0 plus 0, 0, 0 plus 1 is 1, 1, 1, 0, 1, yeah. And then 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. And the rest are just going to be 0 plus 0, which is 1. So now that's the new, we just did this plus this, and then we store that in R1. So R1 now is equal to, I'm just going to break these into chunks. So it's equal to 8, 0, 2, E. So now those are our values of everything after executing all of these instructions. And then this was just like for the memory storage that we did have to use at one point in time for like when we did like the loading of that. So now these are the final values. So let's check our answer. So we have R0 is C. R1 is 82E, 82E. R2 is 8. Sorry, it keeps, I don't know why it doesn't do that. So 8, 2E, and 6, 6. 8, 2E, and 6, 6. Okay, and then that's it.